Hi everybody. In this video you will be learning how to do the 2D momentum collisions lab. So the very first thing I'd like you to do is I'd like you to go to this website. It's a YouTube video, and while it's not me explaining it, it is basically what you're going to do. Okay, so it's about a 7-minute video. I'd like you to take a look at it and watch the video and see what it is exactly that you'll be doing. It's a very good explanation and tells you exactly everything that you'll be needing to know. So take them a few minutes to watch the video, and when you're done, come back here and I'll explain a few modifications. Okay, so hopefully you've had a chance to go check out the video. So just a few minor changes to the procedure and naming conventions. You will only be doing the steel and steel marble. So one marble will be sitting on that little post that you saw, and the other marble is going to come rolling down the ramp. Okay, so it's just two steel marbles colliding. I'm going to leave out a few different size steel marbles for you to use. Find a set of marbles that are going to work for you. Also, in the video, they said the Y direction. They use the Y direction as being up and down. Okay, and I'm going to call that our Z direction because remember, we're doing this in 3 dimensions. Okay, so we want the Y direction to be left and right from the track. X, the X dimension, the X direction, is out from the table in the direction the marble travels. Okay, so X is, you roll the marble down the ramp, it goes flying straight out. That's the X direction. Left and right from that is the Y direction. Now, ball 1 is going to be the ball coming down the ramp. So if you look at your data table, you'll see ball 1 and ball 2. Ball 1, let's just call that the ball coming down the ramp. And ball 2 is the ball that's sitting on the post and the one that's going to get hit. Now make sure that the ball that gets hit is a bit off-center to the left or right. Remember, they do need to be at the same height. Okay, they need to be at the same height, the same elevation, so we don't turn this 2D problem into a 3D problem, just like they talked about in the video. But make sure that that post is a little bit off-centered to the left or right. So that way, when the ball comes down on the ramp and collides, those two balls go flying off at different angles. Okay. If you have them in a straight line, you are doing a one-dimensional collision, and that's not this lab. You need a two-dimensional collision. Okay, so one thing that students always struggle with is how to fill out this data table. So here's a snippet of the data table, okay, and it's the before collision that students struggle with. Okay. What you're going to be doing, as he showed in the video, is first thing you're going to be rolling the marble down, in this case 10 times. Okay. The marble rolls off the ramp, flies through the air, lands on the carbon paper. And you're going to be filling out where that marble lands, okay, X and Y. From there, you go and find, if you look on your paper, the next data table down where you fill out the velocities, okay, X and Y velocities. Where students struggle is, what about that ball that's getting hit? Remember, that is ball 2 is the one that gets hit. So, ball 1, roll it down the ramp, see where it lands. That's going to tell you the velocity, with some calculation will tell you the velocity before it does any colliding. Ball 2, before collision, this is all zeros and this is all zeros. So if you want, right now, get your data table, fill out a string of zeros here, fill out a string of zeros here. Okay. And then you're going to redo it 10 times with ball 1 and 2 colliding, and that's pretty self-explanatory. You fill in the X and Y coordinates there. Okay. So again, for the table, before collision, you measure and record where ball 1's landing coordinates are. Ball 2 is both zeros. And again, this is really important for you to understand. The position data table is going to be used to calculate the velocities. Nothing more. That's all that we're recording, using that position for, is that way we can move on to the next table on velocities. That's its only purpose, just to help us find those velocities. Okay. Ball 1's landing coordinates lets you find ball 1's velocities before collision. Okay. This is where and how fast ball 1 would be going if it didn't collide. Ball 2's coordinates are both zeros. Okay, because it's not moving. It's not moving. So this is just for completion's sake. They're all zeros, so that way when you divide ball 2's x divided by time and y divided by time, yes, you will get a whole bunch of zero velocities. Okay, and that's what you want because it's initially at rest. Okay. Okay, so once on table 2, once you have those positions, okay, moving down from the position tables, once you have those positions, you find the velocities. Once you have those velocities, you multiply by mass to get the x and y momenta of each marble, both before and after collision. Okay, so let me go back one more time because students always mess this up. We said ball 1's the one that comes down the ramp. Find where it lands. Okay. Ball 2, I'm just straight out telling you, put in zeros right here. And then do your collision 10 times. Find x and y where they go. Now down in this, it's not shown, but in this table that would be down here, divide each of these numbers by the time to fall. Okay. Each of these numbers divided by fall time, each of these numbers by fall time, each of these by fall time, each of these by fall time. I think you get the point. And that goes in down here. If you use a spreadsheet, you can automate this, and it'll take like virtually no time to do the lab, to do your data analysis, if you know how to use a spreadsheet. Okay. And again, this is x and y. X is going straight out from the ramp. Okay, just like a line going straight out from the ramp. And the y is going to be to the left or right from the ramp. Neither of these have anything to do with going downwards. Okay, just to be very, very clear about this. Okay, and remember, the goal is to determine if momentum is conserved. Another sticking point that students have. You need to determine if the x momentum is conserved. You need to determine if the y momentum is conserved. That means you're going to need to do this twice. You'll need one equation and set of calculations for x. Is the left side equal to the right side? If not, what's the percent difference? Do the same thing for the y's. Okay, so let's go back to the data table just to be very clear. Okay, so for x, this momentum, x momentum, plus this x momentum, both before, have to equal after x for ball 1 plus after x for ball 2. These are all momenta. Find those. Find the total momentum before. Find the total momentum afterwards. Okay, and then compare. Just do a percent difference. Okay. Remember percent difference? Percent difference is you take the difference divided by the average of those two numbers. Okay. For instance, if your before is 10 and your after is 8, what would you do? You do the difference. 10 minus 8, that's 2. Divided by the average of 10 and 8, that's 9. So that would be 2 over 9 multiplied by 100 to get your percent. So that's how you do percent difference. Okay, so again, make sure you know how to handle those data tables. And remember, you're going to need to do these sets of calculations twice. once for X, once for Y. Okay, and that's how you're going to be working this lab. Okay. So if you have any questions, you're certainly welcome to talk to me or email me about this. And that is the two-dimensional collisions lab. And I hope this helps.